Okay, let's look at example 3.4. In this example, you have a rectangular plate and it's sitting on some hinges and you're supporting it with this cable here from D to C. Well, what we want to find out is what is a moment at point A right here from this force coming off here of this cable. Okay, so how do we do that? Well, moment is what? Moment is R cross F. Okay, so let's define R. What is R? Well, R is a vector from point A to point C. So I'm going to write it like this. This is different how the book does it, but I'm going to say from A to C. And that is what? Well, in the x direction, it is plus 300 in the I direction, and it is 0 in the j direction, and it goes plus 80 in the k direction. So there's our r vector, 300 I plus 0j plus 80k. Now f, we need to do r cross f. So what is f? Well, f is the force of the vector from C to D, right? Well, we don't know what that vector is, but we know what the vector C to D. So let's do that. D, the vector from C to D, is what? It's going to be minus 300 in the I direction. Again, from here to here. It's going from here to there. So we're going back 300. We're going plus 240 in the j direction. And we're going minus 240 plus 80, so minus 320 in the k direction. Now, why are we doing that? Really, we want to know the direction. We want the lambda, or the unit vector of this. So therefore, lambda from C to D is equal to that vector divided by its own magnitude. So it's minus 300 I plus 240 j minus 320 k, all that divided by its magnitude, which is the square root of 300 squared plus 240 squared plus 320 squared, which this ends up being, by the way, 500. Nice and convenient of them. So therefore, my force vector is given as, we're told that it's 200 newtons right here, right? So it's equal to 200 over this magnitude, which is 500, times minus 300 I plus 240 j minus 320 k. I apologize for the arrows, they're acting a little funny on this, so I get rid of the 2 zeros. Okay, so therefore R cross F can be expressed as the determinant of I, J, K, and R is right here, right? We just talked about R. It is 300, 0, and 80. And F, I'm going to pull the 2/5 out here. And then just to make life a little bit simpler, I'm actually going to get, well, no, I won't. I'll just go with this. It's minus 300, 240, and minus 320. So when we do this determinant, you have the I component times 2/5. When I pull that 2/5, I need to make sure I multiply it by everything. And that's going to be times, it's going to end up being 19,200. So it's the I, and then it ends up being this minus this. And then to get rid of that, so I don't have confusion, the J component, the way I do determinants, I'm going to say minus J times 2/5. And then it's going to be, for the J, it's going to be this minus that, right? And so that's going to be minus 96,000 plus 24,000. So you're going to end up with minus 72,000. And then plus K, the K component, which ends up being come over here to the K, and it's 300 times 240 minus 0, so it ends up being 72,000 as well. 72,000. So therefore, we can write our moment vector as, okay, so we can write this as a moment is, and then I'm going to divide everything by 1,000 to get things into Newton meters instead of Newton millimeters, is, whoa, sorry about that. Let's erase that. The moment is minus 7.68 in the I direction, plus 28.8 in the J direction, and plus 28.8 in the K direction. And all that is Newton meters. So that is your answer. There is a moment vector caused by that cable at point A of minus 7.68 I plus 28.8 J plus 28.8 K Newton meters.